Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss straight lines. In this chapter, the previous class, we have discussed the concepts of exercise 10.2. In that exercise, we have discussed various forms of the equation of a line and some problems related to the various forms of a line. I hope you have learned well the concepts. I hope you have learned the problems on various forms of a line well. Haven't you, my children? Right. Now, today we are going to discuss the concepts of exercise 10.3. Are you ready to listen the class? Right. In this class, we mainly focus on converting or transforming. First, we discuss general equation of a line. After that, we have to convert general equation of a line into different forms of line. And secondly, we discuss distance of a point from a line. And the third point, distance between two parallel lines. We focus on these 3 points in this exercise. Okay, my children? Right. Now come to the first point, general equation of a line. In earlier classes, we have studied general equation of first degree in two variables. That is ax plus by plus c is equal to 0, where a, b and c are real constants such that a and b are not 0 simultaneously. Do you remember this point, my children? This equation ax plus by plus c is equal to 0 is a first degree equation in two variables x and y, where a, b and c are real numbers and a and b should not be 0 simultaneously. Okay, my children? Right. Graph of the equation ax plus by plus c is equal to 0 is always a straight line. If you draw the graph of this equation on a graph sheet, we get a straight line. Okay, my children? Therefore, any equation of the form ax plus by plus c is equal to 0, where a and b are not 0 simultaneously, is called general linear equation or general equation of a line. Okay, my children, remember this equation ax plus by plus c is equal to 0 is said to be general equation of a line. Okay, my children, understood this point? Right. Now, let us take an example to understand this concept well. Here, an equation of a line is given. See this example. Equation of a line is 3x minus 4y plus 10 is equal to 0. If you observe this equation, this is a general equation of a line. In a general equation of a line, the terms will be in this order. First term is x term, and the second term is y term, and the third term is constant is equal to 0. Remember these points, my children. And moreover, in general, we make x term is positive. Okay, my children. So this is a general equation of a line. It is given. Find its slope, x and y intercepts. Okay, my children. So to find its slope and x and y intercepts, let us transform, let us convert this general equation of a line in the form of slope intercept form. Okay, my children, do you remember the slope intercept form of a line? Yes, y is equal to mx plus c. Yes or no, my children? So if you observe that equation y is equal to mx plus c, in LHS only letter y is there, only the letter y will be there. In RHS there are two terms. The two terms is x term and constant term. Yes or no, my children? And observe that points. Yes. So here also come to this solution part. Let us write the given equation. 3x minus 4y plus 10 is equal to 0. This can be written as by writing this equation like this. In the LHS, the term is only y letter should be there. So we have converted this equation in the form of y is equal to mx plus c. Understood this equation, my children? Right. Comparing this equation with y is equal to mx plus c, we have slope of the given line as m is equal to 3 by 4. What is the coefficient of x here? 3 by 4. So this 3 by 4 is said to be slope of the line when the equation of a line is in the form of y is equal to mx plus c. Okay, my children? Right. So the first part of the question is completed. Now come to the second part of the question. We have to find x and y intercepts. So now we have to transform this general equation of a line in the form of intercept form of a line. Do you remember that intercept form of a line, my children? Yes, x by a plus y by b is equal to 1. So if you observe this equation, the first term, the numerator only x will be there, the denominator some constant. Yes or no, my children? Plus the second term, the numerator only y will be there, the denominator some constant is equal to, in RHS there is 1. Yes or no, my children? This is called intercept form of a line. X by a plus y by b is equal to 1. So here let us convert this equation, general equation of a line, into intercept form of a line. Okay, my children? For that, first we are transforming, we are transposing plus 10 to RHS. Then what will you get? 3x minus 4y is equal to minus 10. Understood this step, my children? Right. Now let us divide this entire equation on both sides by minus 10 to get 1 in RHS. What is the constant in RHS? Minus 10. That is why we are dividing this entire equation on both sides by minus 10. Then what will you get here? X by minus 10 by 3 plus y by 5 by 2 is equal to 1. Understood this equation, my children? Right. If you observe this equation, this is intercept form of a line. Yes or no, my children? X by a plus y by b is equal to 1. So by comparing this equation with x by a plus y by b is equal to 1, we have x intercept is a, that is minus 10 by 3. The denominator of the first term is x intercept, and y intercept b is equal to 5 by 2. That is the denominator of the second term. Understood this solution, my children? Right. Now sometimes we have to transform the general equation of a line to the normal form. Do you remember the normal form of a line, my children? Yes. X cos omega plus y sin omega is equal to small letter p. Yes or no, my children? Right. So to transform the general equation of a line to the normal form, we use the following steps. Okay, my children, please remember these 2 steps to transform, to convert the general equation of a line to the normal form. Okay, my children? Right. See the first step. Shift the constant term on the RHS and make it positive. This is the first step. In the general equation of a line, first of all, we have to transpose the constant term to RHS and we should make it positive. Understood this first step, my children? Right. Come to the second step. Divide both sides by square root of coefficient of x whole square plus coefficient of y whole square. In this second step, we have to divide the equation we got in the step 1 by square root of coefficient of x whole square plus coefficient of y whole square. the equation so obtained is in the normal form. Understood this point, my children? Is this point clear? Right. To understand this concept well, to reduce, to transform the general equation of a line into the normal form, let us take an example. Okay, my children, reduce the equation root 3x plus y minus 8 is equal to 0 into normal form. Understood this question, my children? Find the values of p and omega. Here, general equation of a line is given. Understood the question, my children? Right. We have to transform. We have to convert the general equation of a line into the normal form. Do you remember the steps to be followed to transform the general equation of a line into the normal form? Yes. Now we follow the steps. Come to the solution part. What is the given equation of the line? Root 3x plus y minus 8 is equal to 0. So in this equation, what is the coefficient of x here? Root 3. What is the coefficient of y? 1. Yes or no, my children? Can you identify coefficient of x and coefficient of y in this equation? Yes. Now we dividing this equation by square root of coefficient of x whole square plus coefficient of y whole square. By simplifying this number, what will you get to finally? 2. Okay, my children. So we have to divide this entire equation by 2. Then what will you get? Root 3 by 2x plus 1 by 2y is equal to 4. We will have transformed minus 8, had transposed minus 8 to RHS, and we divided that 8 by 2. Then what will you get here? 4. Understood this step, my children? Right. Or here, this is in the form of x cos omega plus y sin omega is equal to p. Okay, my children? Right. Here cos omega is equal to 3 by 2, sin 1 by 2. By solving the two trigonometric equations, finally we get omega is equal to 30 degrees. We have to use the previous knowledge of solving trigonometric equations. Do you remember that point, my children? Right. Then we get cos 30 degrees into x plus sin 30 degrees into y is equal to 4. This is the normal form of the given equation of the line. So by comparing this equation with x cos omega plus y sin omega is equal to p, we get p is equal to 4 and omega is equal to 30 degrees. Understood this is solution, my children? Right. Now let us take another example. Find the angle between the lines y minus root 3x minus 5 is equal to 0 and root 3y minus x plus 6 is equal to 0. Understood this question, my children? Yes, we have to find the angle between these two lines. So do you remember the formula to find the angle between the two lines? Y is equal to m1x plus c1 and y is equal to m2x plus c1. Yes, tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Yes, sir, my children? Right. So indirectly, first of all, we have to convert this general equation of the line into the slope intercept form. Yes, sir, my children? So let us take the given two lines y minus root 3x minus 5 is equal to 0. From this equation, we get y is equal to root 3x plus 5. We transformed this equation into slope intercept form, that is y is equal to mx plus c. Understood this step, my children? Right. Similarly, let us take the second equation of the line. Root 3y minus x plus 6 is equal to 0. Okay, my children? Here also we have to transform, we have to convert this equation into the slope intercept form of a line. So then we get y is equal to mx plus c. So understood this step, my children? So here let us consider this is m1. Here coefficient of x is considered as m1. Here coefficient of x is considered as a m2. So slope of the line 1 is m1, that is root 3, and the slope of the line second line is m2 is equal to 1 by root 3. Understood this step, my children? Right. The acute angle, say theta, between the two lines is given by tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Do you remember this formula, my children? Right. So in this formula, let us substitute the values of m1 and m2. Putting the values of m1 and m2 in the equation 3, we get tan theta is equal to modulus of, what is m2 here? 1 by root 3. So 1 by root 3 minus m1. What is m1 here? Root 3 by 1 plus m1, that is root 3 into, what is m2 here? 1 by root 3. Okay, my children. Now let us simplify these numbers. Finally, what will you get here? 1 by root 3. Tan theta is equal to 1 by root 3. Okay, my children. Right. Here, finally we get tan theta is equal to 1 by root 3. So, tan theta is equal to 1 by root 3. Then theta value is 30 degrees, which gives theta is equal to 30 degrees. Understood this step, my children? Hence, angle between the two lines is either 30 degrees or 180 minus 30 degrees. That is 150 degrees. This is the acute angle between the given two lines, and this is the obtuse angle between the given two lines. Is this point clear, my children? Right. Let us take another example. Show that the two lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where b1 comma b2 is not equal to 0 or parallel if a1 by b1 is equal to a2 by b2. And the second part of this question is perpendicular if a1 a2 plus b1 b2 is equal to 0. Understood this question, my children? Yes. There are two parts of this question. First part is we have to prove that the two lines are parallel if a1 by b1 is equal to a2 by b2. And the second part of the question is we have to show that the two lines are perpendicular if a1 a2 plus b1 b2 is equal to 0. Okay, my children? Right. So indirectly we have to convert these two given equations in the slope intercept form. Okay, my children? Right. So the given lines can be written as y is equal to minus a1 by b1 into x minus a1 by b1. By transforming the first equation of the line, we get y is equal to minus a1 by b1 into x minus c1 by b1. Understood this step, my children? Right. Similarly, if you convert the second equation of the line into slope intercept form, that is y is equal to mx plus c, then we get y is equal to minus a2 by b2 into x minus c2 by b2. Understood this equation, my children? Right. So by observing these two equations, we get the slopes of the two lines. So what is the slope of the first line? m1 is equal to minus a1 by b1, that is coefficient of x. And the slope of the second line, that is m2, is equal to minus a2 by b2. Here also we consider coefficient of x. Understood these 2 points, my children, respectively. Now two lines are parallel. Do you remember the condition of parallelism and perpendicularity of two lines, my children? We use that concept here. Yes, if two lines are parallel, then their slopes are equal. That is m1 is equal to m2. Yes or no, my children? Which gives, what is m1 here? Minus a1 by b1 is equal to, what is m2 here? Minus a2 by b2. Understood this step, my children? Right. By simplifying this, here minus minus gets cancelled. Then what will you get? a1 by b1 is equal to a2 by b2. Understood this step, my children? So the first part of the question is proved. Okay, my children? Right. Now come to the second part of the question. Lines are perpendicular. We have to show that the two lines are perpendicular. then if this condition is satisfied. So two lines are perpendicular if the slopes product of the slopes of the two lines are equal to -1. Do you remember this condition, my children? M1, M2 is equal to -1. So which gives, what is M1 here? Minus A1 by B1 into what is M2 here? Minus A2 by B2 is equal to -1. Here minus gets cancelled. Finally we get A1 by B1 into A2 by B2 is equal to -1. Understood this step, my children? Right. So by converting, by transforming, by moving this to one to that side, finally we get A1, A2 plus B1, B2 is equal to 0. This is the second part of the question. We have proved. Understood this example, my children? Right. Now let us take another example. Find the equation of a line perpendicular to the line x minus 2y plus 3 is equal to 0 and passing through the point ordered pair 1 comma minus 2. Understood this question, my children? Right. Indirectly we have to find the slope of the line. After that, after finding the slope of the line, we use this point to get the equation of a required line. Okay, my children? Right. Come to the solution part. What is the given line? X minus 2y plus 3 is equal to 0. If you observe this equation, this is a general form of the line. Okay, my children. Now let us transform. Let us convert this equation in the form of slope intercept form of a line. That is y is equal to mx plus c. Understood this step, my children? We converted this equation in the form of y is equal to mx plus c. Okay, my children. So by comparing this equation with y is equal to mx plus c, what is the value of m here? 1 by 2, coefficient of x. Understood this point, my children? Therefore, slope of the line perpendicular to the line is m2, that is minus 1 by m1. Understand, my children? Because the required equation of the required line is perpendicular to the given line. So slope of the second line is equal to minus 1 by slope of the first line. Understood this point, my children? Right. That is equal to minus 2. So this is the slope of the second line. So here we got slope of the second line, and a line, and the second line is passing through the point ordered pair 1 comma minus 2. Yes, my children. So by using these two values, we find the equation of the required line. Therefore, equation of the line with the slope minus 2 and passing through the point ordered pair 1 comma minus 2 is y minus y1 is equal to m into x minus x1. Point slope form. Do you remember that formula, my children? Do you remember that form of a line? Slope and point slope form of a line. Y minus y1 is equal to m into x minus x1. In that equation, let us substitute. This is x1 and this is y1 and this is m. So y minus of minus 2 is equal to minus 2 of x minus x1. Understood this equation, my children? Right. By simplifying this equation, finally we get y is equal to minus 2x. Understood this equation, my children? Which is the required equation. Okay, my children? Is this example clear? Right. Now come to the second point. Previously I told you in this exercise we are discussing the first point is converting or transforming the general equation of a line into different forms, and the second point is distance of a point from a line. This is the second point. See this second point. The distance of a point from a line is the length of the perpendicular drawn from the point to the line. Okay, my children, suppose this is a coordinate axis and this is a line ax plus by plus c is equal to 0, and p x1 comma y1 be any point on that plane. So the distance of the point from this line is equal to the perpendicular distance of this point from the line, the length of the perpendicular drawn from the point to the line. So this PM is perpendicular to the line. This length of the perpendicular is said to be distance of the point P from the given line. Understood this point, my children? Right. Let L ax plus by plus c is equal to 0 be a line. This is the equation of the given line, whose distance from the point P x1 comma y1 is d. Let us denote the perpendicular distance, or the distance of the point from the line is d. Draw a perpendicular PM from the point P to the line L. Observe this figure, my children, 10.19. Okay, my children. Then the perpendicular distance D of the line AX plus BY plus C is equal to 0 from the point P x1 comma y1 is given by D is equal to modulus of AX1 plus BY1 plus C by root of A square plus B square. Okay, my children. Derivation of this formula is not needed. Okay, my children. So we are using this formula directly in the exercise. Okay, my children. Right. Please remember this formula well. Please memorize this formula well. Distance of a point from a line is modulus of ax1 plus by1 plus c by root of a square plus b square. Okay, my children. Right. Now come to the last point, that is the distance between two parallel lines. Okay, my children. If lines are given in the general form, that is ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. Observe these two equations, my children. If you observe the x terms, they are same and the y terms are same. In the general equation of two lines, x terms and y terms are identical. If they are same, then the two lines are said to be parallel lines. Okay, my children. Then the distance d between the two parallel lines ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. Only the constants are different. Okay, my children. Then d is equal to modulus of c1 minus c2 by root of a square plus b square. The derivation of this formula is also not needed in the examination point of view. Just to remember this formula well. Please memorize this formula well, my children. Do you remember this formula, my children? Right. Now let us take some examples to understand these 2 points, distance of a point from a line and distance between two parallel lines. Okay, my children. See this first example. Find the distance of the point ordered by 3 comma minus 5 from the line a 3x minus 4y minus 26 is equal to 0. Understood this question, my children? Right. Come to the solution part. Given line is 3x minus 4y minus 26 is equal to 0. Okay, my children. If we observe this equation, this is the general form of a line. Now by comparing this equation with ax plus by plus c is equal to 0, what will you get? A is equal to 3, b is equal to minus 4 and c is equal to minus 26. Understood this statement, children? Right. Now let us consider the given point is x1 comma y1. So x1 comma y1 is equal to ordered by 3 comma minus 5. Okay, my children. Then the distance of the given point from the given line is d, that is equal to modulus of ax1 plus by1 plus c by root of a square plus b square. Okay, my children. Do you remember this formula? Have you memorized this formula well, my children? Right. That is equal to, in this formula, let us substitute the values of a, b and c and x1 comma y1. Then what will you get? Modulus of, what is a here? 3 into, what is x1 here? 3. Understood this first term, my children? Right. Plus come to the second term. by1. What is b here? Minus 4 into, what is y1 here? Minus 5. Understood this is second term, my children? Right. Now come to the third term. Plus c. What is the value of c here? Minus 26. So minus 26. Understood these three terms in the numerator, my children? Right. Whole divided by square root of a square. What is a here? Yes, 3 whole square plus what is b here? Minus 4 whole square. Understood this denominator, my children? Right. That is equal to, by simplifying the numerator, Finally we get 3 in the numerator, and by simplifying the denominator we get 5, that is 3 by 5. Understood this example, my children? Right. Now come to the second example. This example is based on distance between the parallel lines. Find the distance between the parallel lines. 3x minus 4y plus 7 is equal to 0, and 3x minus 4y plus 5 is equal to 0. Okay, my children. If we observe these two equations, here x term is 3x, here x term is also 3x. Here y term is minus 4y, here y term is also minus 4y. But constants are different. Here constant term is 7, here constant term is 5. So we say that these two lines are parallel lines. Previously I told that point. In the general equations of two lines, if the x terms and y terms are identical, the two lines are said to be parallel lines. Okay, my children? Right. Now come to the solution part. By comparing this equation with ax plus by plus c1 is equal to 0, then what will you get? A is equal to 3, b is equal to minus 4, and c1 is equal to 7. Understood these three values, my children? And come to the second equation. Here a, b same, c2 is equal to 5. Understood this c2, my children? Right. Therefore, the required distance d is equal to, what is the formula? Do you remember that formula, my children? Distance between the two parallel lines? Yes, modulus of c1 minus c2 by root of a square plus b square. Yes, my children? So in that formula, we will let us substitute a, b, c1 and c2. Then what will you get? Modulus of c1. What is c1 here? 7 minus, what is the value of c2? 5. Understood this numerator, my children? By square root of a square. What is the value of a here? 3. So 3 square plus, what is the value of b here? Minus 4 whole square. Root of a square plus b square. Understood this denominator, my children? Right. By simplifying these numbers, finally we get 2 by 5. So the distance between the given two parallel lines is 2 by 5 units. Is this example clear, my children? Right.